Welcome back to Turbo Gogo, everybody. This week we're checking out these Toyota 86s. They look good, they handle great, but unfortunately, the FA20 that they come with can't cut it. These things have been swapped with everything imaginable, but Dad decided to keep it in the family with an EJ25. Let's check it out. Swapping a Subaru engine back into these 86s isn't very popular. Generally, you'll see LSs, 2Js, or K series, but there's a bit of history behind this EJ. Dad and the owner of this car had originally put it in another one and built it, and Dad's going to tell us about the history of that.
This engine was in a Gen 4 Liberty originally, and it made a lot of power, 750 horsepower at the wheels, which is no mean feat out of an EJ. It is a very highly built engine, like it's nowhere near any level of stockness. The problem with it in that car was it was a wagon. It was a very heavy car. It probably weighed 1,650 kilos, and it was a manual, and you can't put a four-wheel drive manual behind these at that power level without having, it was like a straight cut dog engagement gearbox. So not very nice to drive, even though it sounds cool when you're driving down the street on a Sunday. It's really annoying to drive a car like that daily. And it also, obviously, the clutch is the other issue when you've got a manual trans with this much power. Clutch, big, nasty, like twin plate thing that is either on or off. So there was a bunch of stuff against that particular vehicle, even though Ian had it for years and years, and he liked the fact that it was a very boring looking station wagon, but also incredibly fast. But the next step was probably to find a lighter car to put this engine in. So this is a no-brainer. The 86s are very light to begin with. They handle great. It is a Subaru at heart anyway, despite the badges. So he went out, found this car. It was virtually stock engine-wise and that sort of thing. Just had good brakes, good suspension, that sort of stuff, which is a good place to start. So eventually we pulled the Liberty apart, and that was the start of this project.
So you mentioned some engine upgrades before the engine went back in, Dad. What'd you go with?
So the engine is obviously a really well-built engine. It's got everything that you can imagine to handle the power. All we did was put some bigger cams in because some better ones have become available since the original build. These are quad AVCS heads, so variable cam timing on intake and exhaust. And there wasn't that much support for that back when this engine was first built. So it's since had a cam upgrade. And the only other thing we did was the sump. He's got a Roger Clark Motorsport baffled sump, which is really nicely well thought out bit of gear. Oil surge is obviously a potential issue with anything that's fast and can go around corners, which this presumably will. So that's all we've really done. The rest of it is there's a lot of just modification to the EJ to make it work in this engine bay. So the alternator, I've moved over to the where the power steering pump would normally be, because there's no power. This has got electric power steering, so there's no need for a pump. So that's had to be moved there because we turned the intake around to face forwards, which is kind of how the FA20 is laid out, and it sort of works better that way because these engine bays, even though they've got a Subaru engine in them, the engine bay is a lot smaller. The engine's lower in the bay, and it's all been done for like low center of gravity and all that sort of stuff for handling. So the engine went in there pretty easily. It's got those like solid-ish engine mounts on it, and all we needed to do was change the engine angle, which is pretty much all the FA engine is, because that FA20 block is in normal Subarus, which have a really steep driveline angle. That's just the way they're designed, whereas this has a more traditional, 3-degree sort of driveline angle. So all they've done is put spacers underneath the back of the engine mount and to sort of flatten the engine out, and then the cross member is built around that. So there's a lot of part sharing. So all I've done is put some big like aluminium bar, round bar spacers behind the engine mount, and that's flattened it out. Space-wise, there is none. These engine bays are pretty busy and they're well laid out from factory, which the factory has a lot of resources to do that. But once we've sort of fitted that turbo in there, which is kind of the only place you can put it, that's taken up a bunch of space in between the engine and the radiator. The radiator we've upgraded to a big aftermarket radiator because these things work great, but they've got a tiny little skinny radiator in them, and once you circuit race them, it does become an issue. So that's all custom in there. A lot of stuff being messed around with to fit this intercooler. That was in the Liberty. It's a Plasma Man, like 90mm Plasma Man, so pretty nice bit of gear. It fits in there, no worries, but to get everything sort of closer together, I had to do a lot of mods to the, you can't see it, but just stuff like the aircon condenser had to be moved closer to the radiator. So we sort of made all these little changes just to make everything sort of work together. There's a lot of custom tanks in here. That's purely because there's no space. Like, we just had to use the available space, which means tanks had to be made rather than just buying sort of off the shelf stuff. So Matt Rogan from Rogan Industries folded up and welded all them, and then I fitted them and put my own brackets on it. This air intake, it's the same thing with this. I couldn't even fit a pod filter in front of the turbos, so even if I could, it's going to be eating hot air straight out of the radiator, so that was really not the option that we wanted to go with. So I got the other Matt Tomasini, who works for FFM Fabrication, which makes sheet metal airboxes and stuff for Land Cruisers and Hiluxes and all those dusty, leaky things. So he came and you can still see the dots here. That's where he did a scan and designed all this on CAD with a 3D scan, then folded it up. It's very intricate to get underneath here and maintain the area everywhere. And that filter is what they use on like Commodore LS1 over the radiator intakes. So that's a common, easy to get item. It actually all worked out really nice. Once the bar goes on, everything's got its own airflow. It's really nice. Should work out really well. I'm pretty happy with it.
And you mentioned before it was a manual, but now we've gone auto, haven't we?
Sort of. It was just a factory 6-speed manual, which is not a bad gearbox, but it's never going to handle this sort of power. And even though the bell housing shapes are really similar between EJ and this FA20, that they aren't the same. So using that manual is never going to happen. So what we've gone with was we tossed up between 8 HP, which is the latest buzzword, obviously, and the other BMW gearbox, which is a Getrag GS7, which is a direct or dual clutch gearbox. So the reason we didn't go 8 HP is because our friend Joachim from GZ Racing in Sweden, who that's kind of a little bit of a hub for DCT 8 HP sort of technology. He suggested that this engine's RPM was too high for an 8 HP to reliably operate. So we went from 8 HP to DCT, and he's actually made an adapter kit over in Sweden and then shipped it over here with the gearbox and the matching control unit and everything that's going to run it. So we can have a look underneath and you'll see. It looks like an auto, but it's not. It doesn't have a converter. It's just it's got two. I don't think this is time to try and explain how a DCT works, but you Google it.
Yeah, let's go under and check it out. Dad put this exhaust manifold together about 7 years ago when this EJ went into the Liberty originally. It had a turbo coming straight out the flange back then, but for obvious reasons, had a little up pipe made to squeeze the turbo up the top. On these 86s, our exhaust manifold usually will come through past the cross member here, but because we needed a 3.5 inch exhaust, we've had to go over the top, which you can see with that big fiberglass wrap. Now we come down through here, and because of the GS7's bulkiness, we've had to run an oval pipe along under the body, because originally with the smaller gearboxes, the factory exhaust will run inside the tunnel. Jay from Mint Welding and Fabrication ran this 3.5 oval all the way back for us. And then back, once we get past the diff here, we go to 3.5 round pipe through this AES muffler, which are locally made in Wollongong here in Australia. Speaking of the diff, these 86s come with the Toyota G Series diff in them. We've upgraded the Torsen LSD to a 1.5-way mechanical one from OS Geiken, and we've just put some beefier axles in as well because they're a little bit smaller than the axles that you find in chasers and stuff like that. From factory, these 86s come with welded in cross member brackets in here, and whenever any engine or gearbox swaps are done, you generally have to carefully and tediously drill out every single spot weld to get it out, which we've done, made our own cross member bracket, and to fit this big boy in, we have done a bit of clearancing in the tunnel, but we got the job done. Only thing we're waiting for now is our drive shaft. This black bit here is the adapter plate for the GS7 to the EJ. It's made from an automatic bell housing off a Subaru gearbox. The reason it's so thick here and not just a thin plate as normal adapters usually are is because the starter motor has to go on the back of the engine with these ones, and it just gives us some clearance for that. Dad, looks like we've got a lot of sheet metal fabrication going on here. What's all this going on at the front?
Cooling was a major sort of thing that we wanted to address when we putting this car together. It's going to be used for roll racing, circuit racing, and just general driving primarily, not really drag racing because that transmission's not great for drag racing because there's no converter or normal clutch, so to speak. So with this engine, when it was in the Liberty, it did have some temperature issues. So we wanted to make sure that wasn't going to happen in this new build. So all this intricate sheet metal stuff you can see was actually, this is all made by Matt Rogan, and he also mounted these coolers. So what we're trying to do here is trap the air. If it comes through this intercooler, it's got to go through the radiator. Air will try and get out the easiest way possible. So this is trapping the air, so it's got to go through the radiator, so you're getting good flow through it, which is obviously how it works to exchange of heat. We got 2 oil coolers. This one's for the GS7. It's probably overkill because of the transmission because they don't really get hot so much, but that used to be the engine oil cooler, which was up on top where the intercooler would go on a Subaru normally, which is probably not the greatest spot for it, but it was also a free space that we had in the Liberty because it was pretty busy as well. So there's one on either side. That's the engine oil cooler. Engine oil cooling for me is a priority. Engine oil, it does a lot of cooling effect in the engine as well as coolant. So if you got something with marginal cooling, add good engine oil cooling and you will bring the temperature of the entire engine down, take the load off the radiator. Oil's in there doing its job lubricating, but it's also contacting the majority of the surfaces inside the engine, so it will transfer heat into the oil and then you can transfer it out with a cooler. So definitely something that you should think about when you're thinking about an entire cooling package. We've already talked about this intake and stuff, so it's all been engineered, so to speak, to the best of my abilities to try and make everything work the best it can. Once that bar goes back on, you can't really see anything. It's very stealth. So the only thing I haven't done yet is cut some air exit points in the back of these for the coolers to release the air. You've got to be a bit careful with that because there's obviously a rotating wheel flicking stuff around and you don't want it to damage the back side of the cooler. So that'll be something we do just before we put the bar back on and it goes off to get the wiring done.
Notice there's lots of different sensors all through the engine bay, Dad. Can you tell us about
that? Yeah, so apart from the usual sensors that you need to run the engine, which is, water temp, air temp, map sensor, cam and crank, that sort of thing, that's all standard. We've got a lot of extra sensors for both data logging and also active like safety, like engine protection safety stuff. There's EGTs in each cylinder, which is they're already in there from the previous incarnation. Obviously, as much as you'd like to think each cylinder is equal, they're not. They've got different ports, port shapes, that sort of thing, so airflow can change. That gives you different combustion effect in each cylinder, and you can use the EGTs to both sort of sample what's going on in that cylinder, and you can adjust the tune to suit to keep each cylinder very similar, or keep them all happy, so you're not having one cylinder that's leaner than the rest, which can cause engine damage. But that's sort of basic stuff. You can see there's another K-type, which is what you use, a K-type thermocouple. That's what you use for EGTs as well. The ECU that we're using, which we'll talk about in a second, has 8 inbuilt K-type thermocouples, which is really cool. So I've added another one, and that's on the turbo outlet here. And the reason for that is that along with the EMAP sensor, which is what that coil of pipe that you can see underneath there going to a sensor. That EMAP sensor, exhaust manifold pressure, and turbo speed sensor that we got in here, we use those 3 to work out where the turbo is at efficiency wise. If this temperature rises out of the turbo, it's a steady, and then it goes through the roof, that means the turbo is done. Like it's no longer in its efficiency range. So you just stop there. If the exhaust manifold pressure gets too high, which is subjective depending on who you are, ideally that exhaust manifold pressure would be the same as boost pressure. That means the airflow through the engine is working well. Most of the time it's more like double the boost pressure, but that's just more data. You can see if it slowly rises and then goes through the roof, same thing. The turbine is restricting the engine. Turbos have a rated speed where they're reliable. Usually people run them way over what that speed is and they survive. But once you've got that sensor there, you know that you're at, or how far above how far you've pushed your luck. It's just another data point. So we can make sure that the turbo is working efficiently, which then helps the engine work efficiently. A lot of people just push these things, they don't even know what's going on. There's no excuse for it nowadays. If you've got I/O in your computer, or inputs in your computer, you can run these sensors, then use them. For a start, it'll protect the engine, but it also can help you figure out what went wrong with the engine if something does go wrong, or stop it before it does go wrong. So another obvious one is coolant pressure here, which is screwed into the radiator. All those things, fuel pressure, obviously, oil pressure, basic stuff, oil temperature. It's all just helping you tune the engine and also monitor it. So the ECU that we've got we'll probably use half the I/O in it. It's absolutely huge. It's the top of the range max ECU, and I'll explain why we're using that soon. Obviously this engine used to run on a Haltech, which great product, still use them pretty much all the time. The reason why we're using a max ECU is purely because we need it to control the DCT transmission. It will control it. It's basically emulating what a BMW engine computer would output through the CAN line, and the DCT's got its own computer inside it, which is controlling the shifts and that sort of thing. There have been issues with DCTs in the past, which is why they're not used that much, because they used to use external controllers which were sort of wired into the inside of the ECU, and the factory controller removed, and they were very problematic. And when you have 2 gears being engaged at once in a transmission, it usually ends in explosions and metal confetti. So the method of controlling it by leaving it as standard as it was in a BMW, which are very reliable, obviously, had millions of dollars of R&D put into them, and this max ECU is then just emulating a BMW engine computer and communicating back and forth with them. So that's all done like natively inside the max ECU. It's one of the features of them. Max ECU is like Haltech from Sweden, I guess you could call it. It's made in Sweden. And so we decided, instead of adding another transmission ECU, which you can do as well, and keeping the Haltech as the engine ECU, that it would be sort of smarter to just get have an ECU that's just doing it all internally, so there's no potential clashes with communication and that sort of thing, which can cause issues.
One of the coolest things about this build is Dad was able to retain the stock 86 interior, and super satisfying. It's got the DCT shifter. Sounds great. Once we get the tail shaft for this thing, it'll be going off to get wired up, and we'll see it on the dyno for the next episode. It's been Turbo Gogu. Thank you all for watching. Stay tuned for the next one.
Roger.
Good boy. Good boy.